Good morning, students. In chapter 2, acid, base and salts, okay, in part 1 till now we have discussed about what are the acids and bases. We have already discussed the theories of acids and bases according to Arrhenius. Okay, now we'll take a quick revision of acids and base. According to Arrhenius, acids are those substances which releases H plus ions in their aqueous solution, and bases are those substances which releases OH minus ions in their aqueous solutions. Okay, or we can define the acids and bases like acids are those substances which dissociates almost completely in their aqueous solutions, and bases are those substances which dissociates completely in their aqueous solution, that means they releases OH minus ions, and acid releases H plus ions by dissociating completely into the aqueous solution. Now we'll continue with the part 2. We'll discuss today the properties of acids and bases, or we can say the reactions of acids and bases. Then we'll proceed for the salts. Okay, now the first topic of today's class is reactions of acids. Now, acids reaction with metal carbonate. Okay, how acid reacts with metal carbonate we'll see by the reaction. For example, we have the acids like hydrochloric acid plus metal carbonate. For example, we will take Na2CO3. Metal, Na is a metal, carbonate is CO3. So acid is 2HCl plus Na2CO3. It is hydrochloric acid and it is a metal carbonate. So how HCl react with metal carbonate? See, two molecules of Na and 2H, that we can write it as NaCl, okay, plus carbon dioxide plus water. Now we'll see the reaction is balanced or not. See, 2Na, 2Na. How many chlorine is there? 2 chlorine. So 2 chlorine. Now carbon dioxide and water. Carbon is 1. Okay. Now we'll calculate the number of oxygen also. 2 oxygen plus 1 oxygen, 3 oxygen, and in the left hand side there are also 3 oxygen. How many hydrogens are there on left hand side? 2 hydrogen on left hand side, and here 2 hydrogen on right hand side. The reaction is balanced. Okay. Now when the acid react with metal carbonate, it will give NaCl. This is salt, this is carbon dioxide, and this is water. Okay. So in examination, if the question is what happens when acid is treated with metal carbonate, the answer will, when the acid is treated with metal carbonate, it will give salt, water and carbon dioxide. Second reaction of acid with metal hydrogen carbonate, metal hydrogen carbonate. Okay. Now acid will take again HCl, hydrochloric acid, metal hydrogen carbonate we can write like sodium hydrogen carbonate. Sodium is a metal, hydrogen H, and carbonate is CO3. So what happens when acid is treated with metal hydrogen carbonate? Na is a metal, it will be treated with Cl. Okay, it will use NaCl plus 1 hydrogen, 2 hydrogen, and it will take 1 oxygen from CO3, so it will be H2O, and the remaining part is CO2. Okay, 1 oxygen is taken by this 2H, so water molecule is formed, and the remaining one is CO2. Okay, now the question can be asked like that: what happens when acids are treated with metal hydrogen carbonate. What happens when acids are treated with metal hydrogen carbonates? The answer will be, if the acids are treated with metal hydrogen carbonates, it will give salt, that is NaCl, water and carbon dioxide. The third reaction of acid is reaction of acids with metal. Okay. Now we can take example of acids HCl, that is hydrochloric acid, plus metal. We can take any metal. Suppose I am taking Na. Okay. Or I can take zinc metal. For example, if zinc metal is treated with hydrochloric acid. Okay. Now zinc will react with chlorine. It will give zinc chloride and hydrogen gas is released. See, whenever the acids are treated with metal, keep in your mind that hydrogen gas will be released. Okay, hydrogen gas always released whenever acids are treated with metal. Okay, so the question can be asked in the form of MCQ also. What happens when acids are treated with metal and which gas is released? So the option can be carbon dioxide, sulfur dioxide, sulfur trioxide and hydrogen. So the correct answer will be hydrogen. Whenever the acids are treated with the metal, okay, hydrogen gas is released. See, now we'll see reaction is balanced or not. Here zinc, 2 chlorine and 2 hydrogen, the reaction is balanced. Okay, so we have seen 3 reactions of acids. First with metal carbonates, metal hydrogen carbonates and metals. Now the fourth type of reaction we are going to see. Reactions of acids with metal oxide. Okay, metal oxide. Reactions of acids with metal oxides. Okay, now the reaction of acid, we can take example of HCl plus metal oxide, we can take calcium oxide. Okay, calcium oxide. Calcium is a metal and oxygen, metal oxide. Now calcium is reacting with chlorine and it will give us calcium chloride. Okay, calcium chloride and water. See, calcium and 2 chlorine. Calcium is treated with 2 chlorine, so it will be calcium chloride, that is CaCl2 and water. Okay, see, reaction is balanced or not? Here 2 chlorine molecules are there. Here also 2 chlorine, 2 hydrogen. Okay, and 1 oxygen is there. So here it is 1 oxygen. The reaction is balanced. Okay, it is the reaction of acids with metal oxide. Now we can take an example of reactions of acid with bases. Okay, reaction of acid with base. See, reaction of acid with base is known as neutralization reaction. Reaction of acid with base is known as neutralization reaction. Okay, now whenever the acid is treated with base, the product will always be salt and water. Whenever the acids are treated with bases, the products will be salt and water. See, HCl, hydrochloric acid plus water. Hydrochloric acid is treated with base. We can take any base. For example, NaOH. NaOH is a base. Now Na is treated with Cl or Na is reacting with Cl. It will use NaCl plus water. Okay, it is salt and water. Whenever the acids are treated with bases, the product will be salt and water. Okay, so these are the reactions of acids with various substances. Okay, or we can say these are the properties of acids. Okay, both are same. Now we'll see the properties of bases or the reactions of bases with various substances. Reactions of bases. Okay. Now the first reaction of base you can write with metal carbonate. Okay. The reaction of base with metal carbonate, the answer will be no reaction. Okay. The answer will be no reaction. Whenever the acids are treated with metal carbonates, there is no reaction. The question can be asked, okay, what happens when base is treated with metal carbonates? See, we'll take an example of base like NaOH plus metal carbonate. We can write like this Na2CO3. Now see, Na and Na both are metal, so metals cannot react with metal. Okay, so the reactions of base, that is metal carbonates, the answer will be no reaction. Answer will be no reaction. Again, we'll take an example of the reaction of bases with metal hydrogen carbonate. Metal hydrogen carbonate. Okay, so the reaction of base like NaOH with metal hydrogen carbonate NaHCO3, the answer will again no reaction. Okay, whenever the bases are treated with metal carbonates or metal hydrogen carbonates, the answer will be no reaction. Okay, the bases are not reacting with metal carbonates and metal hydrogen carbonates. See, Na metal and Na metal. Can metal react with any metal? No. Okay, so the answer will be no reaction. Third is with metal. Okay, with metal. See, bases is react with metal. For example, NaOH plus zinc metal they are taking. Okay, NaOH and zinc. The answer will be, whenever the base is react with the metal like zinc, the answer will be, it will form sodium zincate, Na2ZnO2. Okay, it is known as, this compound is known as sodium zincate. This compound is known as sodium zincate. Okay, now we see the reaction is balanced or not. See, 2Na, okay, zinc, one zinc, oxygen, two oxygen. Now can you tell me what is remaining on left hand side which is not written on right hand side? Okay, see, if we'll see carefully, then we'll come to know that hydrogen is remaining on the left hand side. How many hydrogens are there? 2 hydrogens, so we can write like 2 hydrogens. Okay, so the reaction of base like NaOH and zinc, that is metal, so bases is treated with metal, then it will form sodium zincate, the compound, and hydrogen. See, we know that our examination pattern is like first 20 questions are MCQ type question. So they can ask you, what is the formula of the compound sodium zincate? Okay, so the formula for the sodium zincate is Na2ZnO2. Clear? My suggestion is to you, don't by heart the reaction. You should write the reaction in your rough notebooks again and again. Okay, then you can clear or identify what will be the products of the given reactions. Okay, so the third reaction of base with metal is known as, so NaOH plus Zn gives you sodium zincate and hydrogen. Now the fourth reaction we are going to see, the reaction of bases Fourth reaction of base is with non-metal oxide. Now, this time we will take an example of base like calcium hydroxide. Calcium hydroxide. Okay, calcium hydroxide is basic in nature. Why calcium hydroxide is basic in nature? Why calcium hydroxide is basic in nature? So, you have to keep in your mind that the oxides of metals and hydroxides of metals are basic in nature. Oxides of metal and hydroxides of metals are basic in nature. Okay, we can understand by a simple example. Whenever the metals are treated with oxygen or hydroxide, then it will give or it will be in basic nature. So calcium hydroxide is basic in nature. So base we have given calcium hydroxide. Now the reaction is base with non-metal oxide. Now carbon is a non-metal. Carbon is non-metal. Atomic number 6. Okay. Now oxide we can take O2, that is CO2. CO2 is a non-metal oxide. Carbon is a non-metal, and it is combined with oxygen. So the compound is known as non-metal oxide. So the reaction will be calcium carbonate plus water. Now we'll see the reaction is balanced or not. If it is not balanced, we are going to balance it. Okay, calcium, one calcium on both the sides. Okay, so it is balanced. Carbon, one carbon is also balanced. Now oxygen. Now here two oxygen plus two oxygen. So on the left hand side, reactant side, there are four oxygens. On right hand side, 3 oxygen plus 1 oxygen, 4 oxygens. Okay, it is balanced. What about hydrogen? Hydrogen H2 and H2, balanced reaction. The reaction is balanced. Okay, in examination always check the reaction is balanced or not. Okay, now the reaction of non-metal oxide, reaction of bases with non-metal oxide, and fifth and final type of reaction of base with acid. See, don't get confused. The reaction of acid with base is neutralization reaction, and if the question is asked the reaction of base with acid, then also the reaction is neutralization reaction. Whenever acid is treated with base or bases are treated with acid, the product will be salt and water, and the reaction is called as neutralization reaction. Clear? The base you can take NaOH, and acid again we can take hydrofluoric acid. So see, OH and H will combine with each other and it will give H2O, that is water. What is remaining? Na and Cl, so it will give NaCl, that is salt, and this is water. Okay, so bases with acid and acid with bases, the product is same, that is salt and water, and the reaction is known as neutralization reaction. Okay, now we'll see some information about the salt and then we'll proceed for the pH. Okay, now salts. Okay, now salts. How the salts are formed, as we have discussed in part 1. Whenever the acids are treated with bases, salts are formed. Whenever the acids are treated with bases, the product is salt and water. Now salts are of 4 types. Salts are of 4 types. Okay, how we can identify this type of salt? See, in part 1 we have already discussed about strong acid, weak acid, strong base, weak base. Okay, so Okay. So we have already discussed about strong acids, weak acids, strong base, weak base. See how how the salts are formed by the reactions of different acids and bases. See, if strong acid is treated with strong base, okay, when strong acid is treated with strong base, the product will be neutral salt. Okay, whenever the strong acid is treated with strong base, the product will be neutral salt. Okay, then if the strong acid is treated with weak base, the strong acid is treated with weak base, the product will be acidic salt. Okay, now you can ask the question, or there can be a question in your mind, sir, how will identify the salt is acidic in nature? So the answer is, see, among strong acid and weak base, this is strong and this is weak. So who will dominate? Strong will dominate over the weak. Okay, so if strong is dominant over the weak, then the salt is formed is acidic salt. Who is strong here? In the reaction of strong acid and weak base, who is strong? Acid is strong. Okay, so the salt will be acidic in nature. See, whenever acid is treated with base, the product will be salt only. But the salt will be acidic or basic. Okay, the salt will be acidic or basic. That is depends on which acid is treated with which base. If strong acid is treated with strong base, okay, if strong acid is treated with strong base, now see, we have strong acid and strong base, both are strong. Okay, so the reaction will be neutral. If two containers are strong, okay, there will be no result and the product will be neutral. But if one container is strong and another is weak, okay, so the dominant character will be strong. And who is strong here? Strong acid, weak base. The salt will be acidic salt because acid is strong here. Okay. Now, if weak acid is treated with strong base, if weak acid is treated with strong base, see, acid and base, salt will be formed. But which type of salt? Weak acid, strong base. Now here in weak acid and strong base, who is strong? Base is strong. Okay? Okay? Base is strong. So the salt will be basic in nature. Who will dominate? Acid or base? Okay? Here base will dominate because base is strong. So the salt will be basic salt. And when weak acid is treated with weak base, weak acid, weak base. Now both are weak, there will be no result. So the salt is neutral. Salt is neutral in nature. Clear? The salt is neutral in nature. You can take a snapshot of this. So students, we have discussed how many types of salt is formed by the reactions of acids and bases. Okay? Now we will see what is pH, the concept of pH. See, pH is a concept by which we can come to know that whether the given solution is acidic, basic For example, I have three test tubes. Okay, for example, I have three test tubes: test tube A, test tube B, and test tube C. Test tube A, test tube B, and test tube C. And there are some liquids in all the test tubes. Okay. Now, if in practical I want to identify the given solution in A, B, and C, what is the nature of that solution of test tube A, test tube B, and test tube C? Then how will I come to know that the given solution is acidic, basic, or neutral in nature? So the answer is by pH paper. Okay, by finding out the pH of all the three solutions, we can come to know that whether the given solutions are acidic, basic, or neutral in nature. Clear? Okay. So for example, test tube A has a pH 7, then the test tube A solution will be neutral. For example, the pH of the solution B is less than 7, it will be acidic in nature, and if the pH of solution C is more than 7, it will be basic in nature. Okay. Now the main thing is what are the range of the pH scale. Okay, that we'll see in next part of this chapter. Thank you.